positions as a robotics intern.
Okay.
And currently I'm working in motion planning and simulation for a forklift.
Okay.
That's all.
All right. Glad you could join us tonight.
Thank you.
And she sits 3 feet away from me on the
I
other
was
side.
going to say, so you know Jeff.
Yeah.
Does anybody have any
I think
updates?
this is when we're say our condolences. It was a joke, Jeff.
I want to go around.
I can show my encoders that I've been playing with.
Okay.
So here's what the encoder looks like. You know, we bought these from DigiKey, and as like I posted on the Slack channel that I bolted one right to the back of a motor and it did not work. It was slipping. So John says, "Well, just make an extension shaft." So I fought with this all day, trying to come up with the exact numbers. Then he fired up the lathe and made these adapters. So basically, you put the adapter on the back of the shaft to extend the shaft out, and then this black thing is that thing, the little compression thing you press on to make it work. So since that brings it out, then you have to put an extension block on there to raise it up, and then you put the encoder on like that. And here's one that's all ready to go, except my screws are too long, so I have to stop tomorrow morning at the hardware store and get some shorter screws. So basically, they're both ready to go. So tomorrow we'll know if it's going to work or not. So that's kind of where that's. Oh, then my other thing is the way I did it on mine. The motor I have is essentially a wheelchair motor, but it's actually on that mobility scooter. So I just bought this little coupler. It's got 8mm hole on one end, a 6mm hole on the other end. So you just put it on the shaft and then put the encoder right into there. So you just need a bracket to keep the encoder from turning. So just a lightweight bracket that keeps so the encoder doesn't spin. And that probably would have been much quicker than wasting 2 or 3 days trying to get this thing built and running. But it's on there now, so tomorrow we're going to hook it up and see if we're getting good enough information to do us any good. So that's where that project's at.
So is the shaft coming out of your motor, is that the one that has the D slot? Yes,
it is.
And did you, on that part that you cut out on the lathe, did you put a D slot on that?
No, that's a smooth shaft, and it's actually long enough because the original shaft is too short to put the motor right on the back. So I shouldn't have done that in the first place, but I thought, boy, this could have worked great. And then we got it all put together and it was slipping. So we're going to try this method and see how this works out.
Yeah, that looked nice, very compact.
Yeah. What pulses per revolution of encoder did you guys go with?
This one we had to have something fairly slow because the controller we're using doesn't run at high frequencies. So this thing actually, it's a programmable encoder, so it goes anywhere from 48 counts up to 2048 counts. You just got a dip switch inside. You set it to whatever you want. So we just set it to the slowest speed, and we're going to try that and see what that ends up giving us.
Oh, that's awesome. That way you can kind of try some things. Really
yeah.
Cool.
And there's another option. This is what Rod did. Rod was the guy that worked here, and he left and he built his own robot lawnmower. And these are the same motors we have and the same encoder. And he's got some kind of a 3D printed bracket that he made on there. So he's got the 3D printed spacer, and then it looks like right here he printed some kind of a shaft that goes over. I don't know if he made the thing like we did, where it's got the this type of thing, or they originally had a big hex nut that screws on the end. It's held onto that with a set screw where the brake would normally hook on. So it could be 3D printed something and goes over the hex nut and gives him a shaft. So that's the way he did it. And if I was a real whiz at 3D printing, I might attempt something like that. But I knew more about machining and playing with that kind of stuff. So I wasted my time doing that, trying to get that to work.
Never a waste if you enjoy it, that's for sure. And it looks nice too. I think the metal's probably better durability wise than some of the 3D prints anyhow?
Probably. And then the block I put in between, that's the just a piece of plastic that was laying in the back that I guess 10 millimeter thick, and I was agonizing over how to get all these links exactly right. So then when I put the block on, it would be the right spacing and adequate space. And I realized later I could just put an extra sheet of plastic or something if I need more distance. So
I'll throw out one thing I've been able to do in the past is if you don't have a sheet of plastic like that waiting around and you don't want to wait for McMaster, cutting boards that you can get at the grocery store, like the same kind of HDPE material, kind of handy.
yeah, I've seen people do that before, and that seems like a great idea because usually I think about it, I don't. I always think, well, do I have to go to a surplus store? Or do I have to go to somebody that sells real plastic? And they simply use a cutting board, and that's a great idea to do that. That's all I had to say on that, I guess.
It's awesome. Looking good. Al, you want to give us a progress report?
Let's see, a progress report. So probably the best way to do that is to show you a picture or two. Bear with me a second. So I have been share screen. Where did my picture go? Make that a little larger. So the progress that I've got is I have the Super Servo with the teensy inside of it, accepting a average speed data coming from another teensy that's connected to the axle. So I'm reading in actual data. I'm reading in command velocity, linear X command, and I'm transmitting back a PWM signal to the to the Super Servo. So this flat line is what neutral is. This high line is 1500, which is what I've maxed out my Super Servo at the moment, and you can see, it's getting 1.0 on command velocity and feeding back into the transmission of 1500. So this was all driven by, linear X was driven by a joystick, and so Matt had to help me figure out getting my joystick data incorrectly, and after a few version control problems with my software, and after running out of gas, and after the battery dying and needing to be charged, I'm pretty close to driving it out of the garage. So I did move the wheels ever so slightly to figure out what I'm calling it a nudge variable. If you're familiar with the velocity module in Matt's program, you'll know that there's a set amount to compensate for getting the tractor to move past the initial move, and so I figured that out. So I'm getting pretty close to driving it around with under joystick control. So that's pretty cool. And learning a few things along the way about how to use RQT and how to plot stuff out, and all the other challenges you face when you're trying to get this stuff working.
What does your transmission software look like for that piece of it? I think I've seen Matt's, but would you be willing to talk through kind of at a high level?
Yeah, sure. Hold on a second. All of this is on the G drive, by the way. I'm just pulling it up off of.
Okay, I'll take a look there. I haven't really explored that. So. a walkthrough is definitely helpful there too.
So the version that's out on the Google Drive is slightly behind this, but
Can you bump up the font size?
remind me how to do that.
Might be under File and Preferences.
File preferences,
Edit Preferences.
edit preferences.
Maybe not possible. Maybe under Text, under, I don't know.
What happened?
Oh, there's preferences.
Okay.
This is Sublime, remember?
Font, yep. Control plus equal.
How do you do control plus equal? How's that?
Yeah, that looks pretty good.
So again, this software I'm showing you now runs on the Teensy that's in the inside the Super Servo, and the principal reason, I've got something sitting on the Teensy is if there's not a command velocity statement, it sends a neutral value to the transmission. So the way these Super Servos are configured, at least for Matt and I, if you applied power to the Super Servo without the controller operating, it'll want to throw it into reverse. So this is, the principal reason that's doing that. But I've got, velocity control module running at, I think I'm running it at 10 hertz. And so that velocity control function effectively is using Matt's logic to do a partial PID and ultimately, write the transmission, the PWM value to the transmission servo. And then I do some publishing that PWM just so I can see it. So it's not very complicated.
Okay, it's your transmission's similar then to the mats where it's a hydrostatic drive. You push forward, you go forward.
Exactly like.
Okay.
Yeah, exactly like. And so you work out, some key values like, what do you want your reverse value to be? What do you want your neutral value to be? What do you want your full forward to be? This is that nudge factor that just barely moves the wheels, which is fed into the calculating the PWM value.
Yeah. Okay.
Things are always a challenge, just figuring out what's your, in this case, P and I values. That I really haven't done yet because I haven't had it out of the, well, I've tested setting it with it up on blocks, which is what those values worked for, but, having it on ground is going to be a different story. Which hopefully won't be complicated, but another interesting thing that I did that sort of helped in the debugging process is I was using some of the extra command velocity values to set the P and I, and then using, let me show you my instructions. Why is that not bringing up Google like I want it to? So this is a document that I try to work and keep up to date that sort of documents my steps, but the process to figure some things out was helped by using a command like this. So I could send a command velocity and use the timeout function, and this would only then run for 3 seconds. It's what the 3 is for. And I could vary these values and use these values as input to change the the KP and the KI without having to recompile the program. So that made the setup process a little bit faster. So that's a little trick if you're trying to keep from having to recompile your program constantly as you're getting things tuned in.
Okay.
So, Matt, does that about cover it?
That looks nice, Al. Very good.
Cool. Yeah, thanks for walking me through that.
Ross, any updates on your teleop progress?
Well, I got the steering wheel to go, and I started stitching in some things, but then I decided that it would be best if I had something to actually drive with the teleop. So I set that down for a little bit and started working on the transmission, hence all the questions, because I'm trying to figure out which way to really go now. And so I started working on all my modules. I'm going to make CANBus, which is probably going to come with its own set of headaches, but that's what I've decided to do. And so I have a microchip CANBus analyzer, and I got the Linux kernel to compile for that, and you just load the kernel module for it. And then I got the Socketcan ROS module to compile, and it looks like when I use the Socketcan interface portion of ROS can open, that it is indeed trying to actually connect to the microchip CANBus analyzer. And so that's about all the further I've got. I need to use the Socketcan bridge portion, which I think you do Socketcan node, or it's Socketcan bridge node, but I haven't made it past that to actually start, having a device that's connected to it, which I've got a STM-F103 board with a microchip transceiver on it, and it runs FreeRTOS that just spits some messages out at 50 kilohertz. That I'll be using, but I haven't got the data back actually into the computer yet, publishing on topic. So if anybody's done that piece of it and can shed some light on the options to use with Socketcan bridge node or something similar, then that would be useful. That's as far as I've made it so far.
We run that, but I can't, right offhand, I can't think what the options are on it. One of the things you want to do when you're running ROS and running CAN, go and do an ifconfig command. So if you start up CAN, you do ifconfig, your CAN shows up like an Ethernet type interface. And when it shows up, it'll say you've got transmit buffers equals 10, which is the default. So if you set that up to, all the Ethernet stuff runs at 1,000 as the queue size. So we just crank ours up to 1,000, because otherwise if you're running ROS and you say output 6 CAN messages in a row, bam, that fills up 10 of your slots right there, and that'll come back to bite you real quick. So you want to increase the size of that transmit queue. And in fact, even then, we recompiled the Socketcan. If you go down in the Socketcan bridge, there's one that says like what does it say? It says topic to Socketcan and Socketcan to topic. Inside of there, they've got some queues, just the standard ROS queue on the stuff when they start them up, and we made those larger also.
Okay, that's a great tip, because that's something that could fill up, and then I don't know what the behavior is, but I can see that.
Oh, it just crashes immediately when it does that, and you don't know why. So that it took us a long time to figure that one out.
Well, definitely noted there. That's a great tip. Matt, I saw that at some point on it looked like Ross Industrial. You had also compiled Socketcan or Ross Can Open. I say that because I had the same compilation issue. I didn't use the Ross steps to install the dependencies automatically, and that was something I had to go figure out.
Yeah, I actually used a different socket node. I did go through, I had a device that was can open, and so I was using that driver to connect to it. But I used a Python node for my CAN interface. And then I had a CANBus or USB to CAN device.
I tried to use the Python. I found that one as well, and I gave it a shot. I couldn't think of where it was right off the top of my head. I'm kind of trying to flip back through my notes. But I couldn't get that one to work right off, so I tried Ross Can Open, and it seemed to compile and run, so that's why I went with it. But I don't know if you have more experience to share with that regard or not, but seems like this one may work for me.
Yeah, the CANBus interface. I could probably, it's been a while since I've used it, but I could probably try it again. We did end up extending this. I'll post a link to it, but we did end up extending it and adding the messages for our machine in there to parse through those. I have to dig around and find that. It's been a while.
Okay. Yep, that's all I've got with regard to that little incremental progress, I guess.
It adds up. Joe, are you working on any fun projects? Any updates on ROS 2? Listen only mode. Hey, Soen.
Hey, Matt. Hey, everyone.
All right. Great. Are you working on any projects or have any updates?
No, just getting used to life in Chicago for now. Slowly getting back on track. It's nice though. We have a great team and we're at it. So we're going faster, but also farther, which is fun. So yeah.
Adding people helps the velocity of your team, right?
Oh yes, very much so. It's also, if you're working by yourself, you don't really care about how good your code looks or, the readability part of your code. You don't care about anything. You just have it working. And then you find something when you start integrating by yourself, because you'll be working on one module at a time, and then you get to another module, and then you realize, this won't integrate. So you have to go back and do it all over again. And, it's having a lot of people working on different things means you tackle integration on the go, on the fly, and you're always in conversation. If you communicate well, it helps you a lot. So yes, we're also learning as we go. So we're trying to make sure that we make use of all of our past experiences, and also just make use of tools that are available to us in order to manage how we produce outputs or outcomes for our goals. So it's definitely something. It's fun, as I would say, is what I would say. So yeah.
That's awesome. We were working a little bit on the simulator this week, and I don't know if you guys used the introspective feature out of RQT, so you can see what nodes are live and what topics, and then what nodes the topics are trying to talk to. Are you familiar with that feature? Maybe I'll share here. One of the things that we've been working on, like someone is saying, it's one thing if you get your machine working, your robot working, but then working with others and communicating that, how it works can be a bit of a trick. But this is just the Docker container. So we've been finding that Docker has been a little bit easier to move software around complete packages because somebody may have a different Python environment on their laptop, or they may have some conflicts. So with the Docker container, it's clean and everything works and you can bundle it all together. So that part has been a little bit easier. But if you just want to see how, for example, the joystick node flows through your system and gets out to the robot, I just started the joystick node here. Inside of RQT has a feature under introspection, and it's called the node graph. And what this will do is it will map out all of the nodes that are running on your system. And this is kind of helpful once your packages start to get larger and larger and larger as you get things moving. This becomes helpful. And so you can kind of zoom in and see, okay, this is the Joy node. This Joy drive node is publishing to a topic. The topics are squares. So we know that it's publishing to Joy. And then this drive teleop, this is a node. It's listening to the topic Joy, and it's publishing two places. It can publish to command velocity, and it can publish to this move base actions. So inside of this teleop drive, there's actually a button mapped to cancel your autonomous path. And so that's what this link is going into, this move base package here. But teleop is publishing to command velocity, and command velocity is what your robot is listening to move. In our case, it's stage. It's the simulator that is listening to the joystick. And then the stage takes in the command velocity message, and it will output your odometry message where your robot is located. It's also producing laser scans. That is the obstacle detection that we have. Like you see the little red dots on the robot as it moves near this block. That's what that scan is, those little red dots. And then it's also publishing a TF. It's publishing where your transforms of your robot, where things are located. We have another topic, or another node that's listening to the ODOM topic, and it's called ODOM to LLA, and basically just takes in your local coordinates and then creates GPS coordinates. So that was this is a neat tool if you kind of want to watch the flow of what's talking where and how messages are moving through which ones. And if you're, for example, if you know that this drive teleop node needs this Joy topic, it needs to listen to this, and then you don't see this Joy node open, then you have a problem there. So you can start to drill down on each of your systems and take a look. Any questions on that?
I see the scan message, and I know that we're primarily looking at sonar sensors, but imagine I was just wondering if we were to add a laser, uh, would this scan message also go back to the map server, informing the map of an obstacle, or is that set up yet? Or
Exactly. Yeah. So this scan is publishing data to an obstacle layer in MoveBase. So that's its job. That's why scan is this green arrow is connected to this MoveBase node.
thanks, that's what I thought. But I was sure.
And Tractor Viz is visualizing the in our Viz. So as the systems get bigger, tools like this become handy. You can start to keep track, and maybe it's a way that we can use to communicate how each of these packages works. It does take some time to go through each one of these nodes, each one of these circles, and then understand what it does. You know, in the simulator, everything is working for you, but it is helpful to take a look at each one of these nodes and see what's happening and how they're set up. But you have a working demo that you can go back and forth and then explore how those are all hooked together. Hopefully.
So is this Docker image on Docker Hub? I've seen Gross Agriculture username on there, but I haven't been there in a while.
Yeah, you can just pull it down. It is on Docker Hub, so you can pull the full image down. It's there. It's also on the GitHub site on Tractor Sim for Ross Agriculture.
All right. What are the next steps? What are some of the features you'd like to see after you know what else do you need on there? Is what I'm asking for.
That's a great question. I have been working through, Al's got like a list of milestones. And so kind of part of the goal is how to combine all that, make that easy so people can get moving faster and learn these processes. So it'd be taking a look at some of those use cases. And one use case we have is driving a path. Al's A-B line test. And so we have a node that will calculate your off-path error. And then we've been using that peer pursuit algorithm. So we haven't been using MoveBase, but one of the next steps is to keep working with MoveBase and then be able to send in a path with MoveBase and have it follow that path. And so Teb will do that. Teb will, you know how we did it before where we would give it a waypoint and the MoveBase would move and then stop your vehicle and then go to the next waypoint and stop your vehicle.
Yes.
Yeah, we didn't want that behavior. We wanted to drive. But Teb, you can do via waypoints and it will keep your velocity steady and it will just keep on moving through your list.
That's cool. Yeah. I was curious because I remember you mentioning at some point during one of our conversations, one of our many conversations, about move-based flex, and yeah, how about that?
Yeah, move-based flex works. So that would be one upgrade to the simulation.
Is that my internet or did we lose Matt?
I think we lost Matt. Does anybody want to do some magic tricks? Puppet shows?
We could. I saw a really cool YouTube video the other day that is I can't remember what it's called, GTK2 or something like that. It you put a trigger in it, it generates text data, but it's very it uses inference, probabilistic programming and inference models. So it's really good. So we should just like simulate a Matt with the downtime. What he would have said, it'll guess it based off of what he said before.
Matt's back, I think.
Technical difficulties, sorry about that.
So you were saying, or you were talking about move-based flex.
Yeah, I was wondering what, if you're interested in, are you interested in adding some functionality to the simulator?
Yes, and I've been reading through documentation about move-based flex. It's so promising, being able to employ state machines. I think it's a great approach because in our case, there's many possibilities. Or there's many advantages of using state machines because imagine if you have a tractor on the field and you want to pause uh, your path to say refill, or if a tractor breaks down or something, you want to be able to resume. I think state machines would work well. Traditionally, with just simply move base, it wouldn't be uh, we won't be able to employ those things uh, to work for us. And so I think it creates a lot of possibilities, and particularly a waypoint based navigation as compared to explore a path and explore because we have a map pre-built, predefined, as compared to exploring a map. I think that would be, or that should be a way to go for us. Um, so I'm still looking into it. There's not much documentation on it. There's a few tutorials. I believe there's 3, and they mentioned that they're working on a pause functionality, or that is something that would come into the future. Looking so yeah, I'm really looking forward to it. There's also another thing that they mentioned about support for Ackerman machine or vehicles, which would be nice to have a built-in support for that. Uh, I mean, if we have that, then we can start using navigation stack and recovery behaviors uh, for for our robots, which would be nice. So, yes.
So the Docker container just pulls down the Ross lawn tractor project and builds it inside of the Docker container. So if you want to create a branch on the Ross lawn tractor and switch out move base or move base flex, that's cool. And if you just if you, on the first version of it, if you just want to keep the global planner the same and keep tab the same and just swap out move base for move base flex, then we can extend it later for the recovery behaviors and some of the other features. But if
move-based flex primarily builds up onto the move base, so we should be able to use deb local planner because because it's a swappable thing. I'm still trying to understand it, but no, it sounds promising and worthwhile to pursue it. So that's why I ask.
Yeah, if anyone's interested, they can always make a branch of the Ross lawn tractor, add functionality, and then we just check that back in. And then the next time we build the Docker container, it will pull down those changes, and then it will be uploaded to Docker Hub. So then everybody can can test out that package.
It would be nice if you were to go through how you set the Docker up and some other things around that. What were the challenges that you faced, and how were you able to overcome those? That would be an interesting topic to discuss.
I think, yeah, Docker is a little bit of a challenge. I used another person's Docker container that had the format all done. And then, so I just had to add cloning the lawn tractor project down into the container and then running CatCan to build the package. But I think Ross posted a video tutorial on setting up Docker containers.
And how about those really nice shortcuts you have there? Are those bash files or bash scripts?
That's just part of Ubuntu desktop. That's an Ubuntu desktop icon file.
Interesting. Thanks.
And I can show you those if they're pretty simple. There's not much in there, but I can show you how those are set up to launch if you're interested in launching a file.
I think it's a great tool for learning. It helps minimize mistakes when you're starting to learn. So I think it's pretty cool.
Okay. Let me pull it up. So like launching a launch file here. This is how you set that up. Okay. So I don't need the terminal. So basically, on your desktop, so these files get copied into your Docker container, but in the desktop directory, if you just create a text file, and then it has the extension .desktop. So this is teleop.desktop file. And then this is the format that you use. And to launch a ROS node, it's a little bit tricky. One thing that was a little bit tricky is that you source your bash, which we're all familiar with. And then the other little tricky thing is I actually open up Terminator to send the command in. And so this is just and, so you're going to do this source the setup bash, and then you're going to start Terminator. And then Terminator has a function that you can pass in a command. So this command equal is a function of Terminator. And then you pass in your normal ROS launch, start. The one thing you want to do is escape any spaces. So this is an escape key. Or if you have a front slash, if you have a front, for whatever reason, let's say you have a front slash, you have to escape that also. And this backslash is how you escape those characters. And so this is what you use you pass this into Terminator and as a command, and then that's how you launch a node inside of your Docker container. Or actually, this desktop script will work on your own laptop. So you can just copy this and then run it on your laptop if you wanted to launch a ROS launch and have your own icon. And then you just tell it, the other thing you do is you tell it where your icon is that you want it to show on your desktop.
Nice. Thanks.
RQT is a little bit different in the sense that RQT, you can run RQT right from the command line. So you just type in RQT and RQT opens. And so in this case, the difference is you source your setup bash, which is normal. This is the opt ROS, or you could do your local CATCAN workspace, but this is the main ROS workspace. And then you just do and RQT, and then it will launch RQT for you. So if you want to have an RQT icon on your desk your desktop that you just double click, it'll start like that. And then this is the location of the RQT icon or the ROS icon.
What items did you include in the Docker container? Is this Terminator, for instance, does the Docker file install Terminator and some of those other items?
Yeah.
Right now.
Yeah, I did. I threw a bunch. I didn't throw a bunch. I threw kind of what maybe normal. So Terminator's in there. I did install Visual Code, and then most of the ROS packages. So I did desktop full. It's a pretty big file. I mean, a pretty big install, but I just put everything in there. And I may start to include more just so we can do demonstrations of the different things that ROS can do, and it will work for you. You won't have to install anything.
Okay.
I did install like Arduino, so I could put the example files for controlling steering and reading a ROS topic from an Arduino device. So you can just go in there and install it, and then you have a working example. That was a little tricky for me to figure out how to set all that up, but there's pretty good examples in that ROS lib.
Okay. Yeah, I see libgen 3, Python CATCAN tools, less Vim, Terminator, Git core, bash complete, wget.
Are you looking at the Docker file J2?
I'm looking at the Docker file in ROS lawn tractor.
Okay. So that is a dead link now. It's the tractor sim. ROS lawn tractor. It's under. It's called tractor sim now. That's the new.
Okay, yeah, I see the various Docker files.
Yeah, this one's a lot more complex. This Docker setup is a lot more complex, but you edit the Docker file .j2.
Okay. Oh yeah, it's got a bunch more in it.
And then I mainly added underneath builder, so like right around line install ROS, so line 146 and below.
Oh, I see. Okay.
Line 146 to line 266. I could share that so everybody could see if you're interested. Have a quick overview of the J2 file. So this is the lawn tractor sim that's out on, this is out on GitHub. But in here is the configuration for how to build that image that's on Docker Hub if you want to build it from scratch. And you can come down here and take a look at all the things that are installed. But about line 146, so right here, install ROS. Underneath here is where ROS gets installed. And then some packages, desktop full, some plugins for RViz, the ROS serial for Arduino, so we can communicate to that. That was installed. And then some programs like Terminator and Vim and different editors. also installed Arduino.
Uninstall Emacs.
Do what?
I said, does it uninstall Emacs? Sorry.
Yeah, yeah. Lisp. So under here is where we do the lawn tractor. So like if you want to make a change to the lawn tractor or add some functionality, you can make a clone of this, or make a branch of this, edit the changes, and then when we build this Docker file, it will pull down the new branch. I did pull down the tractor teleop, trying to standardize on a teleop message. And this GeoNav transform just converts between lat long and local coordinates. And then we install Arduino here. And then with Arduino, you need to run this. This actually makes that ROS lib file. And so it allows Arduino to compile with ROS. And then I did install VS Code. I was going to try to install the extension for ROS, but I wasn't quite sure how to do that from the command line. So if you're interested in Docker and how all that goes, it's yet another tool that you can learn and spend quite some time on. The never-ending skills of a roboticist. But if you want to specialize in DevOps, we're definitely looking for someone to keep that clean and keep it working and update it. Got about 5 minutes left. Anything else you guys want to discuss? Sam, you want to tell us about your project or what you're interested in learning?
For now, I'm just working on some simulation, trying to add up like multiple laser scanners on the forklift simulation. So basically, I'm going to spawn the robots on top of each other and add laser scanners in different locations and try and get a single map out of it. That's the idea. So yeah, we'll be working on it.
Are you using a 16 scan laser as in the simulation?
So for now, it's in the simulation, it's working on a Hokio laser, but in actuality, we'll be using the SICK laser scanner, and that's like a 360-degree laser scanner. So, yep.
Is it planar? Is it only one scan?
Yeah, it's 2D.
Okay. That's fun. So you just take two Hokoyu scanners and make them output 180 and put them back to back to get your 360, and then try to output that on one scan topic?
No, it's not like that. So because one's placed in the front, one's placed in the left, and the other's placed in the right. And I kind of want like only one map to be generated. So it's a bit of a task. I'm reading on things like how to do things and how others have done it. So the best solution is not using G mapping, but I still want to try and use it. So yeah, I'll keep you guys posted on how it goes.
Okay. It's if I don't know if I'm understanding it right, but it's sort of it could be similar to like multiple robots, their scans all going into one map.
Yeah, I'm going to try that approach. But it can be like you can just like add multiple topics and then try and merge them.
Hmm.
But that's a different approach. So we'll see.
Okay. I know that multi-robot map building is a little bit tricky. There was a class on the construct the last couple weeks. There's a two-part class, 2 hours. I mean, it's an hour each time, but they.
Yeah, I did see the videos today. The videos they posted on YouTube. So yeah.
Okay, good.
I guess in that case, you could combine the data before, whereas like in multiple robots, you kind of have to do additional transforms to combine the data, right? So can you use something simple like sift first and then not simple like sift, but to combine the data?
I haven't tried that, but yeah, I'll see.
Awesome. Anything else for tonight? If not, thanks for being here. It's interesting hearing how things are going. And Al, I hope you have a productive week and you can drive around. We want to see videos.
And not hit the neighbor's cat.
Yep. All right. You guys have a great week.
Good night, all.
Night.
There you
Thanks.
guys.
Bye bye.